The torque converter is connected to the crankshaft via the drive plate. Its mass also acts as the flywheel to stabilize the engine. A starter ring gear is fitted on the outside of the converter for use by the starter. The inside is an enclosed space in which a special fluid, the ATF, transmits torque. Therefore, the torque converter can also be considered as a type of fluid coupling. Fluid coupling. The operational principle of a fluid coupling, which is used in a torque converter, is a simple process. First, think of a fan. Normally, a motor rotates the blades to force air to move. Now, take the same fan, but this time with the power off. If we were to force air to hit the blades will begin to rotate in the opposite direction. Now imagine two fans set facing each other. Turn on only one of these fans to start its blades rotating. Then the blades of the other fan should start to rotate in the opposite direction. This phenomenon demonstrates the operational principle of a torque converter. In a torque converter, a special fluid, the ATF, is used instead of air. And in order to hold the fluid and increase the efficiency, the whole assembly is enclosed in the cover. The fluid that flows through the vanes of the turbine is then guided back to the rear of the pump's vanes within the enclosed space. There the returned fluid pushes the rear of the vanes and assists the rotation of the pump. Torque converter. Now, let's look at an actual torque converter and see how the fluid flows. This part that is rotated by the power of the engine is called the pump. This part that rotates via the motion of the fluid is called the turbine. The blades are called the vanes. When the pump rotates, the pump sends the fluid to the turbine. The fluid entering the turbine is directed towards the center and back towards the pump. The force applied to the turbine during this process rotates the turbine. Because the returning fluid pushes against the rear of the vanes of the pump, the rotation of the pump is assisted by this fluid pressure. This is the source of power that enhances the torque being transmitted in a torque converter. When the speed of the turbine is increased, then the proportion of the fluid flow, which is guided towards the rear of the pump by the stator, is decreased. And beyond a certain point, more of the fluid flows in the direction that is against the direction of pump rotation. If the stator is allowed to move freely once such a state is achieved, the force that works against the rotation of the pump will not increase any further, and power loss can be kept at the minimum. At the same time, power assistance generated by the returned fluid will no longer be there, and then the torque converter becomes just a simple fluid coupling. The point at which the stator is allowed to rotate is preset. This switching point is called the coupling point, or the clutch point. Lock-up mechanism. The lock-up mechanism functions to lock up the torque converter as one unit. Because a torque converter uses a fluid medium and therefore some internal mechanical loss is unavoidable, 100% transmission efficiency cannot be achieved. This is one of the reasons why it's said that the fuel efficiency of an automatic transmission is lower than a manual transmission. The lock-up mechanism connects the torque converter cover and the turbine by a clutch. It allows the engine rotation to be transferred directly to the gear unit without relying on the pump inside the torque converter. Therefore, 100% transmission efficiency of the rotation can be achieved at this point.